So let me go over this as everyone's trying to fight each other to get into class late. So a couple of things I need to talk about because I don't want you guys like surprised and then being like, ah. So I sent out an email to everyone yesterday. So yesterday around like 1 or 2 o'clock, the pre-calc teachers. Oh, I have it right here. Yeah, around 2 o'clock, I think the pre-calc teachers finished up. We finished up the midterm and the review. So I have posted a review for the midterm. It is up. It is optional. It can only help your grade, just like last trimester. So just so you guys know that. Gosh, everybody's coming in late. So next class is going to be a review day. So I'll go over all the big topics that we discussed. The midterm exam will be your assignment. So it's going to be the same process as last time. So I'm going to post on Google Classroom the test as a PDF. So you will look at the PDF. You will do all your work on a separate piece of paper, and then you will take pictures of that work and post it to Google Classroom. So it should be a familiar process. Does anybody have any questions or concerns just about that before we dive into more Law of Cosines? The crowd goes wild. Oh, guys, don't ask so many questions at once. You're overwhelming me. It's either that or is my internet not working? Can you guys... how many questions are on the midterm? That's a great question. Like, I want to say 5 or 6. It's not very many. I mean, so again, guys, if you look at our grading scale, we de-emphasize tests because for a lot of reasons. I don't need to say all of them, but the whole point is it's just an assessment of, are you retaining information that we're giving? Like, are you able to do the information that we're asking? So that's really important that we do that. Okay. So again, 80% of your grade is assignments, and that's where the bulk of your grade is. Also remember that you have to show your work. If you write the right answer but you don't show your work, I won't give you credit. So I don't care. So especially since it's a take-home test, like, showing your work is what I'm looking for. I'm looking for your reasoning. I'm looking for your thinking, right? Stuff that I don't get from WebAssign. Okay. So yeah. So the questions, I don't know. I think there's like 5 or 6. The reason why I'm struggling is that we've worked on it for like 3 weeks, and so like it went from like having 12 to like, you know, down and back up. So I can't remember. It's not super long. It's totally doable in 3 days. How about that? Like, really doable. Like, this is probably one of the most doable pre-calc tests I've ever made. Partial credit, my friend. Partial credit. Right? Especially if your logic is sound. Right? You guys have seen me teach. Like, do I make mistakes? Does that mean I'm not qualified to teach? No. I mean, like, we make mistakes. So if you're showing all the correct logic and like you drop a negative, right, I'll give you partial credit accordingly. Okay? Trust me, guys. I'm not out to get you. I want you guys to be well. And I want your grade to reflect what you know, so that if you apply for colleges, they can be like, oh, this kid gets it. All right. If there isn't any other questions, we're going to dive into Law of Cosines, the 2. All right. Oh, yeah. That's how I get my workout in. Once, you know, I lift up the book twice and we call it good. All right. So today we're going to look at a little bit more difficult problems with Law of Cosine, and we're going to call it good. So again, as always, you guys should interrupt me in a polite way and ask me questions if I do something that doesn't make sense or is confusing, or if I'm going too fast. All right. So Law of Cosines, remember, so the cool thing with Law of Cosines, we derived this last class. It's just Pythagorean theorem for non-right triangles, which is totally cool because remember, if you did, a lot of you guys didn't have me for geometry. I always talk about who Pythagoras is and like why he's such a big deal. So you have to remember, Pythagoras came before Jesus Christ, and I'm not saying the Lord's name in vain. That's the person's name. So he was before Jesus, and and he was the OG Jesus. Like, and I'm not joking. Like, he created a cult following. He walked on water. So there's stories about him walking on water. So like, come on, like, come yeah, religions with crap. No, this is history with crap. This is history. Uh, uh, or cults with craft. That gets weirder. Okay, so like he walked on water. He did all these miracles. So like he was kind of like he was like, that's why there was a cult with him, right? Can you imagine if Pythagorean's religion survived and Jesus's didn't, right? Then we'd all be worse. You know what I mean? So, anyways, where am I getting to? So the fault of his, and I love this story, is that he was really big on Pythagorean, and he was right. Everything in the world can be written as right triangles. Where he made a mistake is he said that these right triangles are all made up of whole numbers. Well, as you guys can tell so far in your math, right triangles and triangles have all sorts of decimals and fractions and square roots in them. One guy, a famous story is one guy called him out on this, and so he took him on a boat and he drowned him. Ooh, dark, right? Also, an important note is that Pythagorean is the most yeah, I know, fun story, good story, cool story. Pythagorean is the most prominent vegan of his age. He was vegan. Kind of cool, right? He the story goes, I mean, you have to remember, anything from that time period is not historically, like, it's not history like we think it is. They told stories, and then that's our account of the history. And the story goes is that the Romans were coming after him. Gosh, the Romans were really big into killing people, huh? The Romans were coming after him, and he was running away, and he was going to get away, but he came upon a chickpea field, or a garbanzo bean field, and he was like, I can't run through this field. I've killed the plants. And so they killed him. That's how the story goes. All right, so let's do some Law of Cosines. Oh, and then to get to revenge on the Romans, all his cult members went out and slaughtered a bunch of cattle and killed all the livestock. That's recorded too. So, vegans getting revenge. I'm gonna make sure you don't eat those animals by killing those animals. I know, right? Like, you guys are like, man, I should have had you for geometry. You should have. It would have been a lot more fun, probably. All right, so let's talk about Law of Cosines. Oh, Wendy, you did. Yeah, I know. Wendy, we're tight. We're down. You heard that story before, right? Wendy, like, please tell me I told that story. I think I did. I love that story. It's my favorite part of geometry. Heck yeah, heck yeah. Oh, that's right. Hey guys, you know what? I did. So it's just this list is so long of people. I had quite a few of you in class. I did. You guys are wonderful. I'm so excited. I'm blessed to have you guys multiple times. All right. Hey, I'm talking a lot. Let's get some work done. Okay, Law of Cosines. So what we're gonna do is we're gonna do word problems. Okay. So I'm gonna read you the problem, and then I'm just gonna draw a picture. So the problem goes like this. You have a pitcher's mound on a softball field, so we're going to do a softball field rather than a baseball field. So a softball field, the only difference is the dimensions are different. So it looks just like a baseball field, a softball field. It's just the smaller dimensions. Okay, so in a softball field, the field is 43 feet from home plate to the pitcher's mound, and the distance between the bases is 60 feet. So from home to the pitcher's mound is 43 feet, and then the distance, and you have to remember, a baseball diamond isn't a thing. A diamond isn't a shape. It's a square. So the distance between all the bases is 60 feet. Yeah, right. PETA is accused of doing stuff like that all the time. It's a common thing. History repeats itself. All right. Okay, so with all those dimensions, it's going to say how far is the pitcher mound from first base. Okay, so again, the distance from home plate to the pitcher's mound is 43 feet. The distance between bases is 60 feet. We want to know what's the distance between the pitcher's mound and the first base, because the pitcher's mound isn't at the direct center of the baseball diamond. So let me draw you a picture the best I can. Okay, so let's see if I can get my pentagon action going on. You know what? I'm not drawing these bases correctly, so I'm so sorry. All right, okay. So if you've never played baseball before or softball, This right here is called home plate. This is called first. This is called second. And this is called third. And then this is the pitching mound. I'm just going to call it PM. Okay? So from the problem, we know that in a softball field, this distance is, and this is professional. I don't know if this is, maybe if someone here is on the softball team, maybe you can tell me if our schools is this set up. So this is 43 feet. Okay? And then we know that this distance is 60 feet. And we don't know this distance. Okay. So I like starting here because this is a really relatively easy problem to solve because it's pretty straightforward and there's no craziness going on. Okay. So what's going on here is we want to know the distance from the pitcher's mound to first base. Now, if the pitcher's mound was exactly in the center, then it would be really easy, but it's not. And the reason for that is because baseballs don't care about perfect geometry. They care about making the sport fun to watch. So one thing you might want to do if you're presented with something that is a picture is you might want to simplify your life. And what I mean by simplify your life, it reminds me of Parks and Rec. Treat yourself. Simplify your life. No, so you might want to simplify your life and just go like this. Okay, so then you take the complexity of it, right? So and mathematicians and scientists do this a lot, right? You take something that's complex, you make it simple so it's easier to do the math. Okay, so to do this, notice how, oh, there's one thing, sorry. So this right here is perpendicular, so this is 45. I'll give you that. So this is 45. And that's because the pitcher, this is a perpendicular bisector. So it is lined up there. So the pitching mound is a perpendicular bisector to home plate. And they do that because it wouldn't make sense if the pitcher was offline, right? That would make everything weirder. So it's straight down the middle, so it bisects that angle, so it's 45. Okay, so we have an ASA triangle. We want to find side X. Now, unfortunately, this is in a law of cosine problem, so it's like, I should use law of cosine. But remember, what's cool, you always want to try to use law of cosine first, because law of cosine doesn't break. Law of sine does break, right? That's when we have the ambiguous case. If you can, always try law of cosine first. So let's take a look and see if we can. So if I call this, and remember, we can call it whatever we want. If I call this A, and then this would be little a, and then if we call this little b and little c, let's see if we can go ahead and solve for a. So I would have a squared equals b squared plus c squared minus, and then I have 2, and then times these inner ones, so times b times c, and then cosine of angle A. So I also am a physics guy, and it's always important. It's the same thing as with physics. You should always draw a picture, identify what you have, and then see what equations you can use, right? That's always the process. Picture, identify, okay, what equation can I use? Okay, and that's for physics. In math, it's not always that way. Okay, so let's see if we can replace some things. So I'm looking for a squared. B is going to be 60. C is going to be 43. And do you guys see how it doesn't matter which one I label? Because you would just be switching them and adding, so it doesn't matter. And then I have 60, 43, and then cosine of 45 degrees. So again, I'm starting out with like the most simple of word problems, and that's what we are doing today. We're doing applications of law of cosine. So just a heads up, you guys are gonna, that's what your homework is gonna be. It's gonna be word problems. Now remember, word problems can be frustrating. It can cause you to get stressed. It can cause you to get frustrated. Remember that that's okay and it's normal. Okay? You guys thought I was gonna say I was gonna help you. All right, now I'm going to take square root of both sides. Now, remember here, and I don't want to be lying to you, when we take the square root of a square, we lose an answer, so we have to do plus or minus. But because we're finding a physical distance, the negative answer doesn't make sense here, right? So we would normally have to write plus or minus the square root, but because the negative answer doesn't make sense in this situation, we're just going to leave it off. All right, calculator time. All right, so let's take a look. The square root of 60 squared. I'm just going to leave the parentheses off because it is a positive number, so I don't have to worry about that. Minus 2, and then parentheses are easy for multiplication. And then cosine. Am I in degrees? Yeah, I'm in degrees. Cosine of 45. And then I just have to put a parenthesis, an extra parenthesis at the end for the square root. Okay, so that sometimes can throw people off with the extra parenthesis, right? So if you want to see what I'm talking about, and the shortcut here is second left. Right here, you see that parenthesis at the very beginning? That's for the square root. So I have to make sure I go all the way to the end. Do you guys know that trick? If you hit second and then the arrow, it goes all the way. It goes all the way, all the way. I might have been alive in the 80s. Okay, so I hit that, and I get side A is 42.43 feet, and boom, there you go. That's how far away, approximately, the distance is from the pitcher's mound to first base. Pretty cool, right? Pitchers, by the way, have awful times throwing to first base because of a couple things. One, the distance is different. Okay, and then two, they're up on a mound. So, and they're used to throwing down, where usually your first baseman, you want to throw it to their hand. So, it happens. Guys, that was really quick. We doing okay? Any questions? Any comments? I think I'm losing my mind. Doing good, like I should. All right, let's do another one. All right, let's do another application. Okay, so I'm gonna read you the problem, and then we'll draw a picture, and then I'm gonna have you guys solve it without me. Okay, so I'm gonna read. This is story time. You guys ready? This is story time with Mr. Kraft. Okay, so a ship on water is traveling 60 miles due north and then adjusts its course. Okay. After traveling 80 miles in the new direction, the ship is 139 miles from a point of departure. Describe the bearing from point B to point C. Ooh, I'm going to tell you guys right now, you're going to solve this using law of cosine, but after the midterm, when you guys come back, we're going to do vectors. So that's what we're going to do after the midterm. And this is going to be so much easier with vectors. And then can I get a what from everyone in here that's in physics? In the chat, give me a what. Do I have any homies that are in physics? Oh my gosh, Constantine, I love you. You are amazing and wonderful. Ah, sorry, that came out. That shouldn't have come out. I just wanted everyone to know that. Okay. So if you're in physics, the next unit after the midterm is going to be really easy for you because it's adding components. And if you've done force diagrams, you add components. So anyways, let's get into this problem. Okay, so you have a boat. Okay, so we start here, and then it says we go 60 miles due north. Okay, which can get confusing because remember, due north is considered 0 degrees in nautical directions, but in mathematical directions, due east is 0. So we're going north 60 miles, and then it says it travels 80 miles in a new direction. Now, it does give a picture, so we're going to go this way, and we're going to go 80 miles, right? Now, if this problem had just done one direction, right, it would have been so much easier. But story of my life, right, it's not. Okay, that was yeah. Thank you. I appreciate. I was just waiting for it. It's kind of like this one of those like you're hanging out with teenagers, and then like you do something super cringy, so that the teenagers are like, "Oh no!" I love doing that. Okay, so and then it says that in total the ship has traveled 139 miles as a crow flies. Right? So if the ship went here and here, if they had just gone straight, it would have been 138. And here I can draw a boat. All right, there's my boat with like the world's worst mass. Okay. So what we want to do is we want to find no. We want to find this. We want to find what was their change in angle. So they were going north. I want to know what this angle is theta. So find theta, and that is their change in direction after the first 60 miles. Okay, so you have this triangle. You want to find angle theta, or because I didn't label anything. So I want to find angle theta. I want you guys to do that. I'm going to give you a time limit. I'm going to give you 2.5 minutes. Okay, so you're going to find that angle right there. For bonus points, you can write your answer as a nautical bearing. Okay? If you don't know what that means, that's okay. Just find the angle. But for bonus points, find your answer as a nautical bearing. And what I mean by that is like how many degrees northwest, southeast kind of thing. The timer ran out and I forgot about it. That's embarrassing. Are you guys doing okay? Do you want a little bit more time? Are you guys ready for the breakdown? Shakedown. I'm gonna just assume, since I'm only getting 1 or 2 people sharing, that you guys need a little bit more time. You know what? I'm going to give you guys 1 minute. And if you're already done, then you can sit there and enjoy the fact that you're done and reflect on it. If you finished early, reflect on this. Is a hot dog a sandwich? All right. I'm going to go over this. If you have questions, let me know. Okay. So, I want to find this angle. Okay. I know the side opposite, and I know the other 2 sides. So, I don't know the alternate way, and I'm just going to write it the way I know. So the side of the angle I'm looking at squared equals the other 2 sides squared minus 2 times those other sides, and then cosine of the angle I'm looking for. Now, some of you guys started out with the alternative form. Cool. I don't have that memorized, and to be honest, with my life, I don't have room to memorize more stuff, so I'm not going to. All right, so I'm going to go ahead and solve this. So I'm going to start by subtracting the sides. Boop, 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 boop. Okay, let's see what we get here. I get 139 squared minus the 60 squared minus the 80 squared, and I get 9,321, and that equals negativo 2 times 60 times 80 times cosine of theta. Actually, that makes a really good point. I don't know how to say cosine and sine in Spanish. I would assume it's just cosine and sine because they're Greek words. All right, so now that I get here, I get something times cosine, so I'm going to get rid of that something. So I still got this number in here, so I'm just going to go divide, and it'll automatically do the answer for me. And then I have negative 2 times 60 times 80. Ooh, and I get the world's ugliest number. So we talked about this, we ticky-talked about this, is that you're just going to keep it in your calculator, but write it down just in case, your calculator deletes it by accident. Accident. Just like my dog ate my homework. I guess now the internet eats your homework, right? Okay, so I get to this. I still want to get to theta. So my last step here is I'm going to do inverse cosine of both sides. Right, that gets rid of the function there. So in my calculator, I'm going to do inverse cosine. I'm in degrees, so make sure you're in degrees. And then second answer, right? If you have a fancy TI graphing calculator, you might be able to copy and paste. And then I'm going to hit the enter. So I get approximately 166.15 degrees equals theta. Now, the problem here is that this is totally our answer. Now you can be like, Kreft, you just misspoke. Why is that our problem? The problem here is this is totally our answer. But if you were to tell someone on the boat, oh, if you want to get here after 60 miles, turn 166.15 degrees, the captain of that boat will look at you and be like, what? Right? Because that's not in nautical coordinates. So to get this in nautical coordinates, you have to remember that due north is 0 degrees. So if this is north, then I am going some amount over here, right? So to do that, I'm just going to go 180 degrees minus 166.15, and I get, what is it, 13 something? Yeah, 13.86 degrees. So you would write that as north 13.86 degrees west. Now, if you didn't know how to do that, that's okay. But you know me. If I have an opportunity to teach you something, I will. So you start with the heading, and then so this is your heading, and then you're going to turn to 13.86 degrees this direction. Okay? So you can imagine if it wasn't due north, there would be a number in front of it. So I'd be going, my original heading was 14 degrees due northeast or something, and then I'm going to go 13 degrees west. You're not going to do this on your homework. Do you really think I'd be that mean to you? I mean, maybe. Wendy, yeah, I probably would. No, I'm not going to do this to you on your homework. This is fine. All right, cool. If I do that to you on your homework, I'm really sorry. You can email me. But I didn't. Okay. We're going to do one last one. So I'm going to let you guys vote. So here are your options. So in chat, you guys can say hashtag boat or hashtag softball. Oh, wow. Okay, softball wins. No. I'm so impressed with the speed at which the answer was given that I'm going softball. That was insane. All right, okay. So in this new problem, a batter comes up to the plate and hits a ball into left field. Then the left fielder picks up the ball and throws it to second base, and we're going to find the distance there. Okay, so let me draw. Let me show you the world. Okay, can you imagine this is a baseball field? Okay, looks like pizza. So hashtag pizza. And then this is home plate. This is first base. This is second base. This is third base. This is the pitcher's mound. Okay, the ball gets thrown. It's a line drive ball. Okay. And the ball's right here, and it gets hit 160 feet. Okay, put some power into that swing. And then, let's see here. What else do we want to do? Okay, they're going to throw to second base, right? If you've never played baseball or softball before, outfielders almost always throw to second base because you know you're not going to throw them out at first base, and you want to dissuade them from getting the second. Okay, and then this distance yields 85 feet, and this is 45 degrees. So I want to find the distance of the throw to first base, or second base. All right. So I'm gonna give you guys. Last time you needed a little bit more time, so I'm gonna give you 3:30. Okay, and let's do it. I want you guys to have some success. I want you to feel good about yourselves. Uh-oh, what's that in right field? Is it a boat? Are we out of here at 12 or 12:10? Okay. Do you guys need a little bit more time with this? And I'm just saying, if I was playing baseball, I think I would stay out of right field. It seems like there's a lot going on. Like the Titanic woman is like flying in the wind. We know how that ends. And then you got the most dangerous of dangerous fish. You got whale sharks, or shark whales. I don't know which one it is. It's hard to identify. All right. So let's go ahead and solve this problem. Whale sharks are really nice. Okay, so to do this, I want to solve for x. So, okay, so I can say, okay, x squared is going to equal the other two sides squared, the sum of the other two sides squared, minus 2 times those other two sides, and then cosine of the angle opposite of x. So again, in this one, I'm going to yeah, the dugout. Well, I don't know. I mean, look at the dugout. The dugout looks like it's got a lot of pre-calc going on. I don't know. Is that where you want to be? Doesn't seem like, as a coach myself, it doesn't seem like the dugout's really paying attention to what's going on. You know what I mean? Like, my teammate out here is having delusions of flying while there's a shark whale underneath, and they're just doing math problems. Like, come on, dugout, help out your teammate, you know? And there's a game going on apparently too. So, all right. So how do I solve this? Well, I'm going to take a square root. Now, normally, again, I'm going to have to do plus or minus when I do this, but then I don't think the outfielder is owing the second baseman a throw. You know what I mean? Like, you know what? I'm not going to throw it to you. I'll owe you one. I'll get you one next time. Okay? No, they're going to throw it now. So we're just going to take the positive one. So I'm going to have the square root, and then I'm just going to type this all into my calculate height. Or now, remember, you have to be in degrees, and x is approximately, I think it's about 117 feet. Yeah, the other dugout is, they're probably like, what is going on with this team, right? That's probably what's going on. As someone who has coached C team a lot in my life, I've definitely been there before. On both sides. Okay, talk to me, guys. Are we doing okay? Are we not doing okay? That's really it for today. We're just going to practice word problems. If I'm looking at your homework, 1, 2, 3, 4, 5, 6. There's only 6 problems. So very doable, very manageable. Hey, Constantine, I will let everyone in this class go if you promise one thing and say it to everyone in chat. And this is what you need to say. You're going to say, class, I am going to do this assignment and turn it in on time. And then if we do that, I won't do another problem and we can all leave. No pressure. Oh, okay. Bye, everybody. Take care. Your homework, if it's not posted yet, will be posted soon. Don't forget that there is a review up for the midterm, so you guys can work on that.